Good evening, guys. This is from IIT and SCAPE classes. Myself, Navneet Krishnan. I have been teaching for IIT and SCAPE classes in flight mechanics for almost a decade. In this today's demos class for GATE 2007, we'll start with the range and endurance of a given space. In this, if we start with range and endurance of a given flight, first we have to understand what is range. Okay. So, range is nothing but the maximum horizontal distance covered on a given tank of fuel. But the maximum horizontal distance covered on a given tank of fuel. That means initially when you are starting a flight, the full weight of the aircraft is present. That means full weight of fuel is present. Once it has covered the maximum horizontal distance on the flight, the total weight on the airplane will be the empty weight of the airplane. So this distance covered is called as range. So the total horizontal distance covered from point where all the fuel is present to the point where all the fuel is become empty. This W1 is nothing but the empty weight of the airplane. Empty weight of the airplane, which is excluding fuel weight. Okay. This is W. Of the process. This is the definition of range. So if you want to take endurance, so endurance is the maximum time, that is the total time the airplane stayed in air on a given tank of fuel. Given tank of fuel. So at this point, the time was T0. When the airplane has consumed all the fuel, the time becomes TE. So the total time the airplane stayed in this, the time it has TE minus T0 is nothing but your endurance. Okay. So until the fuel has become empty, the total time the airplane stayed in air, it is called as endurance. It will not be completely empty also, because we will keep some 10% reserve as per the FAA regulations. Okay. So we will keep 10% reserve fuel in case of any emergency. And other than that, whatever the fuel consumed, it is the total fuel which is consumed, the total time is called as endurance. Okay. Is that clear what is the range and endurance definition is? If we are clear, then we'll start with obtaining the equations. So the gross weight of the airplane is W0. W1 is nothing but the weight of the airplane when fuel load is empty. When fuel load is empty. Okay. So the weight of fuel is nothing but W0 minus W1 is the weight of the fuel. So if you want the weight of the airplane at then we have to know what is the weight of the airplane at weight of the fuel engine. So that is the weight.
I think some voice cracking is happening now, Nit. You are using Wi-Fi, right?
Mine is not given, so I'm using my internet via phone.
No, phone is very tricky, man. Okay, but I was not knowing because it's a mobile network now, so
because I shifted back to Pune from Pune to Bangalore.
You are in Bangalore today?
Yes.
Okay.
I joined here recently.
So can you keep your phone at bit distance near window or something, so at least network disruption will be less?
Yeah. Okay. Now okay.
Yeah, it is better. Please continue.
Okay. W is the weight of the airplane at any particular instant. Okay. So at that point, weight of the fuel at that particular instant is nothing but this is WFI is nothing but the weight of the fuel at that particular instant. Okay. So empty weight will be always same. It will not be changing. So weight of airplane at any particular instant is nothing but W1 plus weight of fuel at that particular instant.
Prior to this, I have one question on it.
Yeah.
Why do we do range and endurance calculation? Can you give some brief idea, because you work on UAVs, how it is important in design particular perspective?
When they give basic specification of an aircraft, so first for starting your design, scratch, to start your design, any customer will give you certain requirements. So they want the range of the airplane to be 500 kilometers, and they want the endurance of the airplane to be 4 hours flying or something like that. So it is in the specification itself. They would have mentioned for this specification you have to design your airplane. So range and endurance is an important parameter for design of an aircraft, where if we know how much long the airplane can stay, we can define what is the territory of it is flying. For example, since we are working in UAV for a defense sector, so where whether we want to whether this airplane is capable enough to operate in Ladakh sector or in southern sector, depends on how much range it got. Because if you take Ladakh, it cannot be upper region at all, because already the border is larger than 250 kilometer range. So yeah, for Ladakh, if we have to keep the airplane, it has to be more than a kilometer range. Then only the airplane is suitable for that kind of border. So depending upon the border of operation and fuel consumption, for example, if why range and endurance is important? In case of commercial airplane, it's more. When you are saving more fuel, that means cost is again reciprocal. So you will get everything in terms of cost. So you can get at a low cost. If you have a maximum range, that means you can travel at a cheaper cost. So that's why range and endurance are more important, because if you are able to reduce your cost, that means you are reducing the other effects, like for example ticket price. So your ticket price also might come down because you are reducing the fuel cost. That means you are reducing your surge cost. That way range and endurance is most important in the critical design stage itself. So is that okay? Anybody having any
questions? Ask some questions to a student also. because
yeah.
we know we can teach n number of things, but
Yes.
this demo session is not all about teaching them.
Yes,
So we
yes.
can ask some questions. So if you have any questions to ask them, you can ask them, and then let's continue
Yeah.
this part.
Have you people understood why range and endurance is important?
And
Because it is defined at the specific stage itself. Yes.
and one thing I want to add on, guys, when you work as an aerospace engineer, almost all airlines have performance engineers. In airlines, the only technical role for most of the aeronautical or aerospace engineer is ECA performance engineer role. Even one of my senior was working with earlier that Jet Aerospace was there. Okay, and maybe someone else in this ECA
And
performance.
Boeing also there is a thing special
flight
called
physics.
as flight physics engineer.
Yeah. In fact, Airbus and Boeing also, they have teams, flight physics team. So there, you know, guys, they do all these performance related studies. Yeah, there are different design requirements when you design aircraft. There are propulsion requirement, structural requirement, performance requirement. So in ECA performance, we all deal with performance requirements, okay, related basics. Clear, everyone?
Now, when we differentiate this weight, what happens is it will become dW equal to dWf. Why? Because this W1 is a constant weight, so it becomes 0 when you differentiate. So, but as time progresses, your weight of fuel decreases, so there is a minus sign. Weight of the airplane also decreases and weight of fuel also decreases, so there will be a minus sign. Okay. Now we'll see how to derive an range and endurance equation for a piston engine airplane. Okay. So in piston engine aircraft, the performance, we always measure the performance in terms of power. In case of jet engine aircraft, we always measure in terms of thrust, because in piston engine aircraft, we always get shaft power as your reference. Shaft power of your engine or brake power of your engine as reference. That brake power only is allowing you to rotate your propeller, thereby you are generating thrust. So in piston engine aircraft, always we measure the performance parameters in terms of power rather than thrust. So in piston engine aircraft, we measure power in terms of power, thereby we measure the fuel consumption in terms of specific fuel consumption. The definition of specific fuel consumption is weight of fuel consumed per unit time per unit power. Okay. So if I take unit of SFC, unit of specific fuel consumption, this is specific fuel consumption is most important parameter. If it is least, that means you will have maximum range and endurance. So this is the most important parameter. So we have to consume less fuel for generating more power. That's what the definition says. Okay. So what is that is? It is Newton, weight of fuel is in Newton. So Newton of fuel divided by unit time, which is in second, and unit power, which is in joules per second, or Newton meter per second, or in watts. This is also 1 watt, or it is also Newton meter per second. Okay, the unit here. So it is Newton by second into Newton meter per second. Joule is nothing but Newton meter. So for unit meter, how much fuel is consumed is the unit is called as specific fuel consumption. The unit is per meter. That means for 1 meter, how much fuel you are consuming, that is called as, that definition is called as specific fuel consumption. Yes, Balakrishna. W1 is the empty weight of the airplane, correct. Okay. So, what is this? SFC is nothing but dWf divided by dt into PS. So I am writing in terms of incremental change. Okay, for incremental time, this is the incremental fuel you require. Okay, as time progresses, what happens? The weight of the fuel decreases. Thereby, it's a minus. Okay, as time progresses, weight of fuel decreases. Thereby, minus. Now I am taking dt on one side, remaining all the other parameter on the other side. So dt is equal to minus dWf by SFC into shaft power. We already know that dWf is nothing but dW divided by SFC into shaft power. So when time was equal to 0, all the fuel was present. So weight of the airplane was W0. When time is become endurance E, so the airplane has consumed all the fuel. That means only empty weight of the fuel aircraft is present. All the fuel is consumed. So from this equation, minus sign I am using it for interchanging the limits. So W0, W1. So dW by SFC into PS. So when I integrate it on both sides, I get it as E equal to integral of W0 W1 into dW by SFC into shaft power. So I'll keep this equation as A, equation A, which we'll be using later on. When we are deriving liquid range and endurance equation, we'll be using this equation. So next, I am using this C has become the W0 is your gross weight of the airplane. When time become E, all the fuel we have consumed, because endurance means the total time it stayed in air on a given tank of fuel. So all the fuel we have consumed. That means only W1 will be present, which is the empty weight of the airplane. So this minus sign, I am using it for interchanging the limits. So I have interchanged the limits W1, W0, W1 to W1, W0. Okay. When I integrate here, so it becomes E equal to W1, W0 into dW by SFC into shaft power. So I am writing this equation as equation A. Now again I am taking back the same equation dt equal to minus dWf by SFC into shaft power. Now I am multiplying both sides by V infinity. I am multiplying both sides by V infinity. Okay. When we are multiplying both sides by V infinity, what happens? V infinity into dt will become ds. So ds equal to minus V infinity into dWf divided by specific fuel consumption into shaft power. Now I am integrating it on both sides. So when distance covered was equal to 0, all the fuel was present. When the distance covered is equal to range, that means range is the maximum horizontal distance covered on a given tank of fuel. That means all the fuel is consumed. That means your weight of the airplane is W1, which is your empty weight of the airplane. Again, minus sign, I am using it for interchanging the limits. So W1, W0 into V infinity dWf divided by S of C into shaft power. These two equations, I am using it for deriving required range and endurance equation of piston engine aircraft. Until this, it is clear. If you are clear with this, then it is only matter of derivations. Anybody having any doubt in this? We will be deriving required range equation for aircraft. We'll take the d, which is W1 W0 in V infinity into dW by S of C into shaft power. Okay. So to maximize the range, pilot has set the throttle such a way that power available is equal to power required. This is the one assumption we are making to derive the equations. So power required is nothing but your drag into velocity. So this is throttle setting for level flight he is making in order to maximize the range. Throttle setting for level flight. Okay. So we know that power available is nothing but efficiency of the propeller into shaft power. So your shaft power is nothing but power available by 𝐸 P. So since we have set the throttle power available equal to power required, so power available I am replacing it by power required divided by 𝐸 P. That is equal to drag into V infinity by 𝐸 P. Free stream velocity. V infinity is nothing but the free stream velocity that the aircraft is flying at that velocity. Okay. Now, so I am substituting this back to this equation. So range is, so when we are starting our gate class, it will not be like this. Since every year we teach a different topic in our demo class, that's why we have taken a random topic. In our actual gate class, we'll start from scratch. If W1 W0 V infinity into dW divided by S of C into dV infinity by 𝐸 P. Now V infinity will get cancelled. So 𝐸 P by S of C, I am taking it out of the integration because they are constants. It doesn't going to change with respect to weight of the airplane. Okay, it's not constant. It doesn't going to change with respect to weight of the airplane. So W1 W0 1 by drag into dW. Okay, I am multiplying and dividing it by weight. I am multiplying and dividing it by weight. We know that for level flight only the pilot has set the throttle. For level flight, power available equal to power required, and one more condition is lift equal to weight. That is mean by level flight. Okay. This is also condition for level flight. So one of the W, I am replacing it by lift. Okay, one of the W, I am replacing it as lift. So 𝐸 P by S of C into W1 W0. W, I am replacing it by lift divided by drag into dW by W. So lift is nothing but CL into half rho V square S. Drag is nothing but CD into half rho V square S. This is the basic equation, where CL is the lift coefficient, CD is the drag coefficient. Okay. When I make L by D, it will become CL by CD because half rho v square s, half rho v square s get cancelled. So it will become all in non-dimensionalized form. CL by CD. So when I integrate dW by dW, it becomes ln of W naught by W1. Okay. Ln of, so it is integral of dx by x is nothing but ln of x. When I'm substituting the limits will come like this. Okay. So this is the Brickworth range equation for piston engine aircraft. Okay. So how we can maximize the range of piston engine aircraft? I'm taking back that equation. Eta P by SFC into CL by CD ln of W naught by W1. There are various ways we can maximize your range for a piston engine airplane. First, if the efficiency of the propeller is maximum, then we can maximize the range. How we can maximize the efficiency of the propeller? We can use a variable pitch propeller. So, variable pitch propeller means the propeller changes its pitch throughout its flight condition using a variable pitch propeller. For various speeds, they change the propeller pitch. Thereby, we can maximize the range. Okay. Use a variable pitch propeller. So, when we use variable pitch propeller, at all speeds, the efficiency of the propeller will become maximum. Second, select a engine which is having least SFC. So, engine consuming less fuel for maximum power output. Okay. Less fuel. Thereby, we can maximize the range because range is inversely proportional to SFC. Next, third, range is directly proportional to CL by CD, which means range is directly proportional to CL by CD. This means for maximizing the range, CL by CD should be maximum, which means L by D is maximum. L by D max corresponds to drag minimum condition, which we'll be seeing when start of the class. If we are deriving from the basics, you will understand that L by D max occurs at drag minimum condition. Drag minimum condition is nothing but CD naught equal to CDI, where CD naught is nothing but your parasite drag coefficient, which is nothing but the drag coefficient which is independent of lift. Parasite drag coefficient is nothing but the drag coefficient which is not dependent on lift. It only depends upon your profile of your aircraft. CDI is nothing but the induced drag coefficient, which is induced drag coefficient, which is drag which is created due to lift. That means the drag created due to wing tip vortices. Because of the downwash, this induced drag coefficient is created. Okay. So CD naught equal to CDI is the condition for maximizing the range. Then fourth, range is directly proportional to ln of W naught. W naught is nothing but W1 plus WF. So W1 forget about. That means W naught is directly proportional to WF. When weight of fuel is increased, that means we can increase the range. Is that clear? These are the 4 ways we can maximize the range of the piston engine aircraft. Any doubt in this? Anybody having any doubt in this? If you want to ask any doubt, you can ask. Like whatever we have dealt with, parasite drag means what, induced drag means what, you can ask any doubt. We are ready to help you. In actual class, we will be defining all this in basic itself. Thereby, when we are deriving this equation, it will be less problematic for you. Yes, Balakrishna, do you have some doubt? How fuel weight will increase your drag? It is internal to your aircraft, right? Yeah, because if you are talking in terms of lift is directly proportional to velocity square, drag is also directly proportional to velocity square. So when weight increases, velocity increases. Thereby drag increases. But lift also increases, no? So L by D will increase. So we have to optimize L by D such a way that at what speed L by D becomes maximum. We have to optimize to that speed. Understood? Next, Brickwork endurance equation for piston engine aircraft. I am taking that equation A, which is E equal to W1 W0 dW divided by S of C into PS. Again the same assumptions. Okay. Again the same assumption. Pilot has set the throttle for level flight or cruise condition. So that means power available equal to power required. That is nothing but to drag into V. So shaft power is nothing but power available by neta P. So shaft power is nothing but power available by neta P. So this means dV infinity by neta P. Putting this in this equation, what happens? We get endurance equal to W1 W0 dW by S of C into dV infinity by neta P. So simplifying further, neta P by S of C, I am keeping it separate out of the integration because it doesn't depend upon your weight. So 1 by D into 1 divided by, we have set the throttle such a way that lift equal to weight. Lift is nothing but CL into half rho V square S. So V is nothing but, I'm taking this 2 on the other side, 2W by rho S CL. Square root of 2W by rho S CL. Substitute that here, 2W by rho S CL. Okay. Again, here also I am multiplying and dividing it by weight for simplification. This is this multiplication and division, we are doing it for simplification. Okay. So now one of the lift weight, I am replacing it into lift. So neta P by S of C, W1 W0 into L by D into 1 by root of 2 by rho S CL. This W into root of W will become W power 3 by 2. Okay. W power 3 by 2. This L by D, I am replacing it as CL by CD, non-dimensionalizing it as CL by C. So if we modify it further, it is neta P by S of C into W1 W0 CL by CD into root of rho s by 2. So I am taking it in the numerator. So 1 by value, this will become rho s cl root of rho s cl by 2. This will become root of rho s cl by 2. This cl, I am cl into root of cl, I am taking it outside. So it will become cl power 3 by 2 into dw by w power 3 by 2. I am taking all these other non-dimensionalized parameters outside. Cl power 3 by 2 by CD as, because it is not going to change with respect to your weight. It depends upon more on your aerodynamic characteristics like aerofoil, okay, into root of rho s by 2. Okay. So it is anything x power minus 3 by 2. If we are integrating, what happens? It is x power minus 1 minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1. So it will become x power minus 1 by 2 by minus 1 by 2. Same thing. This is what this. So I am using this here. So neta p by SFC into CL power 3 by 2 by CD into root of rho s by 2 into W1 W0 W power minus 1 by 2 by minus 1 by 2. This minus sign, I am using it for interchanging the limits again. So neta p by SFC into CL power 3 by 2 by CD into this 1 by 1 by 2 will become 2. So 2 divided by root 2 will become root 2. So root 2 into rho s. So this minus sign, I am using it for interchanging the limits. That's what I told. W0, W1, W power minus 1 by 2. So it will become neta p by SFC into CL power 3 by 2 by CD into root of 2 into rho s into 1 by W power minus by 1 by 2 means 1 by root W. So 1 by root of W1 minus 1 by root of W0. This is the Briquet endurance equation for piston engine aircraft. This is the Briquet endurance equation for piston engine aircraft. Any doubt in this derivation? Any doubt in this derivation? Okay. Then we'll solve. We'll see what are the conditions for maximizing the endurance piston engine aircraft. I am writing that equation again. E equal to neta p by SFC into CL power 3 by 2 by CD into 2 into rho by rho s 2 into rho s power 1 by 2 into 1 by root of W1 minus root of W0. So first, increase the efficiency of the propeller at all speeds. So if we are using a variable pitch propeller, we can increase the efficiency at all speeds. Thereby, we can maximize the endurance. Then second, select an engine which is consuming least specific fuel consumption. So select an engine which is having least specific fuel consumption. Then Third, CL power 3 by 2 by CD to be maximum. This occurs at a condition in basics if you would have studied, or when we are teaching for gate, when we are studying, it is nothing but power required minimum condition. Power required minimum condition is nothing but CD naught equal to 1 by 3 CDA. If you fly at this condition, power required will be minimum. When power required minimum, endurance will be maximum. Fourth, E is directly proportional to density. Density at sea level is maximum because as altitude increases, density decreases. When we will be teaching in atmosphere, we will understand this, that as altitude increases, density decreases. So, when you are flying closer to sea level, altitude, sea level altitude, that's where the density is maximum. When density is maximum, endurance is maximum. That means for piston engine aircraft, if you are operating closer to sea level, the endurance is maximum. This is one such condition why piston engine airplane are only restricted to low level altitude, because when we are flying closer to sea level only, piston engine aircraft provides more endurance. That means it can maximize its performance. So that's why most of the piston engine aircraft are restricted 0 to 300 meter altitude only. In feet, if you convert, it will be more than that. But if it is 0 to 3000 meter. If higher than this altitude, it is not allowed to operate because it cannot give you better performance. Because all the thrust is generated by your propeller blade. If the propeller blade is not generating enough thrust, then you cannot overcome your drag. Thereby, you cannot maximize your endurance. Okay. There is one more fifth condition. Increase W0. How will you increase W0? We cannot increase empty weight. Empty weight increases means then you are unnecessarily increasing your weight. That means you are reducing your endurance. You have to not increase W1, we have to increase WEF. If you increase weight of fuel, then you can increase the range, endurance. Because this value, if it is more, and 1 by this value will become less, thereby this will be greater than 1 value, thereby you can maximize your endurance. Is that clear? Any doubt? Any doubt you can ask. Okay. Same way for jet engine aircraft, we'll derive this equation and we'll understand this equation. Then we'll solve 1 or 2 problems, okay, on this section. Thrust specific fuel consumption. In case of piston engine aircraft, we measure in terms of power, thereby we dictated in terms of we add a specific fuel consumption name. Here, thrust specific fuel consumption, it is slightly differentiated from specific fuel consumption. It is because we measure in terms of thrust here. Thereby, the name thrust specific fuel consumption. So, what is the unit of what is the definition of thrust specific fuel consumption? It is weight of fuel consumed per unit time per unit thrust. There it was unit power, Here it is unit thrust. So the unit of thrust specific fuel consumption is Newton of fuel consumed per unit time per unit thrust. So thrust is nothing but Newton. Okay, Newton of thrust. Okay, so it is unit is per second. So how much fuel is consumed per second is called as thrust specific fuel consumption. So per second, if you consume less fuel, then thrust specific fuel consumption is less. Thereby, you can maximize your range and endurance. From the definition, we will write it in integral form. Thrust specific fuel consumption is the weight of fuel consumed per unit time per unit thrust. Since as time progresses, weight of the fuel decreases, thereby minus sign. So this in turn decreases your weight of the airplane. So dWf equal to dW, which we have obtained. Okay, dt into t. Keeping dt on one side, remaining all the other parameter and taking it on the other side. Minus dW divided by thrust specific fuel consumption into t. When time was equal to 0, all the fuel was present. When the time it has become endurance, all the fuel is consumed. So it will be only empty weight of the airplane. Minus sign, I am again using it for interchanging the limits. So W1, W0, dW by thrust specific fuel consumption into thrust. This equation I am writing it as C. If you have any doubt, you can stop me then and there. Then only we can clear your doubts. Okay. Next. Multiply both sides by V infinity. I am taking this equation again. dt equal to W1 W0 dW by thrust specific fuel consumption into thrust. I am multiplying both sides by V infinity. When V infinity into dt is nothing but ds. Because V infinity is nothing but ds by dt, the rate of change of distance with respect to time. Okay. So V infinity into dt is nothing but ds. Okay. I am integrating on both sides. When distance covered was equal to 0, all the fuel weight was present. When distance covered is equal to range, all the fuel is consumed, so only empty weight of that plane is present. So when I am integrating it, r is equal to minus sign, I am using it for interchanging the limits. From this, we are going to derive required range and endurance equation of jet engine airplane. I am keeping this equation as equation 2. Any doubt until now? If you have any doubt, you can clarify. Okay. I am taking that equation B, which is nothing but range is equal to V infinity into dW by thrust specific fuel consumption into thrust. W1, W0. Now, again, pilot has set the throttle such a way that lift equal to weight, thrust equal to drag. So I am replacing thrust as drag. Okay. And since pilot has set the throttle lift equal to W, V infinity can be written as 2W by rho S CL into 1 by thrust specific fuel consumption into 1 by D, because thrust I am replacing it as drag, into multiplying and dividing it by weight. One of the W I am replacing it as lift. So root of 2 by rho S, I am taking it out of the integration, and 1 by thrust specific fuel consumption, I am taking it out of the integration. So it will become W1 W0 1 by root of CL into L by D into dW by W into W power 1 by 2, because this root of W is there. So I am replacing it as CL by CD. L by D in non-dimensionalized form, it is CL by CD. So CL divided by root of CL will become CL power 1 by 2. Which also I am taking it out of the integration. W1 W0 dW W power 1 by 2 divided by W will become W power like this. Okay. Now it is in the form of integral of dx by root of x. So which is x power minus 1 by 2 into dx integral. So when we integrate it, we'll write it as x power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So it will become x power 1 by 2 divided by 1 by 2. So I'm substituting that. It's basic integration. Okay. Root of 2 by rho S into 1 by thrust specific fuel consumption into CL by CL power 1 by 2 by CD so it will become root of W power 1 by 2 W0 W1. So 1 by 1 by 2 will become 2. So this will become 2 into root of 2 by rho S into 1 by thrust specific fuel consumption into CL power 1 by 2 by CD into root of W0 minus root of W1. This is the Brickwork range equation for jet engine aircraft. Okay. Now we'll see how we can maximize the range of a jet engine airplane. So I'm writing down that equation again. R equal to 2 into root of 2 by rho S into CL power 1 by 2 by CD into 1 by thrust specific fuel consumption into root of W0 minus WA root of W1. First, since there is no propeller here, it's a jet engine aircraft. So first, select the engine which is having least thrust specific fuel consumption. If it consumes least fuel, then you can maximize the range. Second, CL power 1 by 2 by CD should be maximum. This corresponds to drag by velocity minimum condition, which is nothing but 1 by 3 CD naught equal to CDI. In previous condition, power required minimum condition, it is CD naught equal to 1 by 3 CDI. Here, it is 1 by 3 CD naught equal to CDI condition. If we are flying at this condition, you can maximize the range. Third, range is inversely proportional to square root of density. As altitude increases, density decreases. When density decreases, that means range increases. So, jet engine aircraft can have better performance at higher altitude compared to sea level. This is why jet engine for high altitude application, that is around about 10,000 meter, above 10,000 meter of altitude, we use jet engine aircraft. Okay. So for high altitude application and high speed applications, we can, because at high altitude means density decreases, so lift is nothing but CL into half rho V square S. So density decreases means we have to increase the velocity to have same lift. So we have to fly at higher speed. So for high altitude and high speed applications, jet engine aircraft is more preferable. Reason is it can, at high altitude, it maximizes its range. Fourth one. Range is directly proportional to square root of W naught, which is nothing but W1 plus WF. W1 plus WF. As weight of fuel increased, range is increased. These are the 4 ways we can maximize range of a jet engine aircraft. Any doubt? Okay. Now we'll derive Brickworth endurance equation of a jet engine aircraft. I am taking that equation C as it is, which is W1 W0 dW by thrust specific fuel consumption into thrust. So pilot has set the throttle such a way that thrust equal to drag, lift equal to weight. So E equal to W0 W1 dW by thrust specific fuel consumption into 1 by D. I am multiplying and dividing it by weight. One of the W I am replacing it by L. So 1 by thrust specific fuel consumption into L by D. L by D can be written as CL by CD. Integral of W1 W0 dW by W. So 1 by thrust specific fuel consumption into CL by CD. dW by W, when I integrate, it will become ln of W. So when I substituting the limits, it will become ln of W0 by W0. This is the Brickworth endurance equation for jet engine airplane. Any doubt here? Okay. Now we'll see what are the conditions we can maximize the endurance.
Sir, I will just wait. I think 1 hour is over. Let's not go further in derivation. You can pick up some...
Only this this one I'll complete and I'll start solving problems, 1 or 2 problems.
Okay, fine, perfect. And guys,
Another 15 minutes.
Apart from Balakrishnan, Ranika, Sailuksa, Prashant, Lakshmi, Kishore, any doubt, Akshita? Because again, I want guys, you should ask some questions because sir is very sincere. He will just keep teaching, but I don't want that. Okay, so be free to ask, like Balakrishnan is asking or responding. So you people to do Sam. Okay, then please continue.
If you'd have seen this equation, E is equal to 1 by thrust specific fuel consumption, CL by CD, ln of W0 by W1. I'll explain that graph also. It is 1 by thrust specific fuel consumption into CL by CD, ln of W0 by W1. So, how to maximize your endurances of a jet engine aircraft is select an engine which is having least thrust specific fuel consumption. When you have least thrust specific fuel consumption, that means we can maximize the endurance. Select an engine which is having least thrust specific fuel consumption. When CL by CD is maximum, we can maximize the endurance. CL by CD max means L by D max. L by D max means drag minimum condition. Drag minimum condition means CD not equal to CDI. If we are flying at this condition, then we can maximize the endurance of the jet engine airplane. Third, the endurance is directly proportional to ln of W0. Then W0 increased, that means W0 is nothing but W1 plus WF. So when WF is increased, then the endurance is increased. Okay. These are the ways we can maximize endurance of a, yes, correct, Balakrishna. These are the ways we can maximize the endurance of a jet engine airplane. If you see this plot, this is the thrust required versus velocity plot. So, for maximum range of a jet engine aircraft, the maximum range occurs at drag minimum condition. So, this is a drag versus velocity plot. So, it is occurred at a condition where drag is minimum, where the endurance is maximum for jet engine aircraft. If I draw a slope tangent to this curve, if I draw a tangent to this curve from origin, this slope indicates drag by velocity. This slope indicates drag by velocity. The point where it is intersecting, that slope is intersecting, the tangent is intersecting, is where the condition for drag by velocity minimum condition. That's where CL power 1 by 2 by CD will be maximum. That is where the range will be maximum. So, for endurance maximum, we have to fly at this velocity. For range maximum, we have to fly at this velocity. So, to have an optimum of these two, we have to fly in between this velocity to maximize range and endurance of a given flight. Is that understood? Any doubt in this? If you have understood, then we'll solve one or two problems so that we can understand this. GATE 2008, question number. In certain question, we add this gate. Okay. To maximize the range of the jet engine aircraft, it should be flown at a velocity that maximizes what? We have derived this equation. Anybody can answer this? We have just now solved it. Anybody could answer this? Yes, correct. Because range of the jet engine aircraft is required range of the jet engine aircraft. We know that It is R equal to 2 into root of 2 by rho s CL power 1 by 2 by CD into 1 by thrust specific fuel consumption into root of W0 minus root of W1. So range is directly proportional to CL power 1 by 2 by CD. So that means option B is the correct answer. Option B is the correct answer. Yes, 𝐀𝐞𝐫, it is correct. Next, GATE 2012, question number. In a second question, they have asked this: if an aircraft takes off with 10% less fuel consumption in comparison to its standard configuration, its range is lowered by 10%, lowered by more than 10%, lowered by less than 10%. It's an unpredictable quantity. It's a little tricky question. We'll understand this question better. Okay, we'll solve this. There are many ways to solve this problem. I'll teach you one way so that when we are solving in actual class also, I'll derive it in a different manner. Okay. So we know that range of the. I'll take one such aircraft, whichever it is easy. I'll taking this as a piston engine aircraft. We doesn't know for both the aircrafts, it behaves in the same way. Okay. For piston engine aircraft, I'll take it. It is eta P by SFC into CL by CD into ln of W0 by W1. So this I am replacing it as eta B by SFC into CL by CD because we want in terms of fuel weight. Then only we can. This is, let us assume this is R. Now R dash is where every other parameter is same, but we are taking the aircraft with 10% less fuel. We are taking the aircraft with 10% less fuel. That means only 90% of the fuel weight is present right now. They are asking what is the percentage change in range. Okay. Now, what is the percentage change in range? It is R dash minus final minus initial by initial value into 100. That will give you in percentage. So, since all the other parameters are same, I am not taking this because when we are dividing it, all this parameter will go off. So I am taking only the parameter which is required. So ln, which is in terms of ln, I am taking that parameter alone. So ln of 1 plus 0.9 WF divided by W1 minus ln of 1 plus WF divided by W1 divided by ln of 1 plus WF divided by W1. This is one such tricky question asked in GATE 2012. In GATE 2012 alone, we have got this kind of similar questions, different kinds of questions, more questions we got. In rate of climb also similar question they have asked. In takeoff also they have asked similar question in GATE 2012. So when I replace this will become ln of 1 plus 0.9 WF by W1 divided by ln of 1 plus Wf by W1 minus 1, because this divided by this will become minus 1 into 100%. Take any one fraction, any fraction value. So for our understanding, I'll take this fraction value as 0.1. Weight of fuel divided by weight of empty weight of the airplane as 0.1. You can take any value to understand this. So if I substitute 0.1, so what happens? It will become ln of 1 plus 0.9 into 0.1 divided by ln of 1 plus 0.1 minus 1 into 100. The value we are getting is minus 9.58%. So what is the answer? It is lower by less than 10%. Lower by less than 10%. If I put 0.2 also, it will be in terms of minus 9% something. So it is lowering by less than 10%. So option C is the correct answer. Anybody, any doubt? Even if you derive the same way for jet engine aircraft also, this will be the same. For jet engine aircraft also, this will be the same, but we will be using different, derived as same. For jet engine aircraft, we have to derive by same. And any doubt, problem will solve it. And this section. GATE 2020. Question number: engine, propeller driven, general aviation airplane condition. Density of airplane at sea level is 1.2 kg per meter cube. This value, if not given also, we have to take this value only. Okay. Sometimes they may not give the density of air at sea level. When it is not given, we have to take 1.2256 kg per meter cube. Since it is given, we are taking this value. With speed to cover maximum range, for drag coefficient CD equal to CD 0.05 plus 0.049 CL square, the wing loading W by S is nothing but 9844 Newton per meter square. What is the speed of the airplane at which? Okay. We know that what is the maximum endurance condition for they have driven propeller driven. So that means piston engine aircraft. So what is the for piston engine aircraft? They want to maximize the range. So range equation is eta P by SFC into CL by CD into ln of W0 by W1. So CL by CD is maximum at drag minimum condition, that is CD not equal to CDI condition. So they are given drag polar equation, which is 0.025 plus CD equal to 0.025 plus 0.049 CL square, which is nothing but CD naught plus KCL square. This KCL square is nothing but your induced drag coefficient, where K is nothing but 1 divided by pi AR, where E is Oswald efficiency factor, AR is aspect ratio. This anyhow will be depending in the basic terms when we are deriving, when we are starting from scratch. Okay. So they are given CD not equal to CDI is the condition. Okay. So 0.025 is equal to 0.049 CL square. So CL is nothing but square root of 0.025 divided by 0.049. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . One second. Until this, it is clear. Anybody having any doubt? So CL will become 0.7143. Okay. Then we can substitute. We know what is the speed equation. What is speed equation? It is root of 2W by OSCL. So for this, that CL we have obtained. W by S is given, which is nothing but wing loading. W by S is also called as wing loading. So 2 divided by 1.2256. W by S value, it is already given, 9844 Newton per meter square. Into 1 divided by 0.7143. So we get the value as 150 meter per second. Because they wanted to round off it 1 decimal places, so it becomes
so 𝐲𝐵, these are simple derivation. You may not understand the physics behind that, but at least mathematics, did you understand?
Why 𝐲𝐵 is from a different background?
She's from mechanical background. 𝐲𝐵, I'm asking one question.
So
see, these are more of simple taking derivations and equating to 0 to find max or minimum condition. Okay. Now the background was given, right? Whenever we design any aircraft, we have to define range and endurance, or those things were predefined, right? The purpose is what? To fly, right? So to fly for a particular range. And what is the other purpose? To know the fuel consumption, right? So that way, in performance, these two parameters are very important. And in GATE, what kind of questions comes? So sir has demonstrated on SAM. Is it clear? So
what for 𝐲𝐵, for you to get conference, there was one time last 2-3 gates back, we had a computer science student who got gate topper from our institute. Second rank guy. He was got a gate second rank from our
EC guy, sir. Sorry, he was EC guy. Yeah. And on top of that, 𝐲𝐵, we have got even 1 digit rank from mechanical, also AR6 in 24. And I have given Navneet all this background in introduction class. Now, 𝐲𝐵, my suggestion to you will be, there are Anderson books, okay? There are Anderson books. So I'll share you, there is one book, or you can buy also, because Anderson books are fantastic for aerospace engineering. One is Introduction to Flight. Can you buy that book? If you want to buy hard copy. So you buy that book and start reading. That book will start giving you some kind of test of aerospace engineering. Introduction to Flight by Anderson, John D. Anderson. Then there are other books like Fundamental of Aerodynamics by Anderson. So get those books. Definitely E-form I will share. Then there is one book called Aerodynamics for Naval Aviator. All of you guys can read that book. That also tomorrow I will avail you guys. Okay. That Aerodynamics for Naval Aviator, you will not find a single equation. It's only theory and derivation. So since it's just Feb month, Renika, Sailuksa, Prashant, you should all read that books. Okay, you will enjoy these subjects later. Aerodynamics for Naval Aviator by H.H. Hart. It is Hart. Yeah. So these all our suggestion. And still I will suggest Navneet sir, please during classes you ask, see, we can teach n number of things, but we have to ask certain questions always to students. Okay, to make sure they are attentive in classes. That is what my suggestion, sir, after this year. Though you have a decade of teaching journey with IGC, because I know it's an online class, na. Some people will sleep, they don't worry what's going in class. Of course, in IGC, we will have all sets of students. Some are too attentive, right? We have seen throughout Balakrishnan, right? He was keeps asking, sharing, but I want everybody's involvement, okay, not just few people's involvement, okay. So please do in that front, in upcoming classes.